Okay, so here are the rules for significant figures. They are sort of random, and I think you'll get a better understanding of what they mean when we just start looking at problems or looking at examples. But let's just talk about them really quickly. First rule is that significant digits, by the way, you can call them sig digs if you want. I wouldn't do that. That's kind of weird, but sig figs is better. Anyway, non-zero digits are always significant. So a number like 151, there are no zeros in there, so all those numbers are what we call significant. They're all important. Zeros between non-zero digits are also significant. So like 101 also has 3 significant figures because this zero counts as a number that we need. Zeros in front, like when you have a decimal point, like right here, decimal point, then these 2 zeros, actually the third zero as well, all 3 of those zeros are not significant. They're just placeholders to get to this number 1. So this one only has 1 significant figure, this number. And number 4, zeros at the end of a number and to the right of the decimal point are always significant, like 121.00. Someone took the time to measure out the 0.00, like they're that exact. And so we need all 5 of those are considered significant figures. If it was like 100 and, let's just say, no. If you are 15 feet tall, 15.0 feet tall, it means you're exactly 15.0 feet tall. Okay? There's no mistaking this. This number is included for a reason. So that makes it significant. And then number 5 is not super important, but you'll see it in a second. And that's it. So the best way is to try some examples. Are you ready? You can write them right at the bottom there. So we have a number like, let's say, well, we just did this 125.0. This number has 4 significant figures because this 0 was written for a reason. It's not just a placeholder. You can write 125 by itself, but when you include 0.0, it means that, yes, I know that exactly, I measured this 0 and that's exactly what it is. And so that is going to have 4 significant figures. I'm just going to put like a circle around it so you know it's got 4 significant figures. A number like 1,000 without a decimal point, that only has 1 significant figure because these are all zeros. They're not smushed in between any other numbers, and there's no decimal point there. So this is the only significant figure or it's the only significant digit is the 1 there. So that's 1 sig fig. However, if I wrote 1,000 point, well, that point indicates that, yes, I've measured this entire thing, and it's exactly 1,000 up to that point. Maybe it's 1,000.5 or 0.6 or 0.1, but right here I know that it's exactly 1,000. So that inclusion of that little decimal point means that it's got 4 significant figures. Am I going too fast, or are we okay? Sounds good. Appreciate your feedback, which was very quiet. Zeros in between, like 10,403. All those zeros are important. They don't just keep a space. They are important they're there for a reason. So that's 10,403. It's got 1, 2, 3, 4, 5 significant figures. But if the numbers are before, there's a decimal point, like a number below 1, and it's, let's say 0.0045. The zeros right here are just placekeepers. Okay, the 45, those are the only 2 significant figures there, so this one only has 2 significant figures. However, if you take the time to write, say 0.0450, and you write an extra 0 after your 5, again, that means that you've measured to this spot, which is a very, very specific spot. And so that 0 does count, while the other zeros do not. So this one has 3 significant figures. This rule, when it's to the right of the decimal point, that's only good for when the number is smaller than 1, sorry. Notice that this 0, these are not significant, but they're to the right of the 1. This one is because the number is less than 1. Oh, hello. Scientific notation, that works too. 7.38 times 10 to the 4th. You're assuming everything after the the 8 is a 0, which is just a placeholder, so the only significant figures are these 3 right here. 3 significant figures, 7.38. Want to try some? Sure you do. That's the spirit. See if you can find out how many significant figures are in 8, 9, and 10. Not the numbers, but the examples. And take a minute right now. Determine the number of significant figures for each of those in numbers 8, 9, and 10. But when you do it, just try not to be super excited about it. No, that's very exciting. There you go. That's the excitement I wanted to hear. All right, so 11. These zeros are placekeepers. There's just they're not in between other numbers, and so that means that there's only 2 significant figures there. How many of you had 2? Raise your hand. Be proud. There you go. Proud of you guys. Next, number 9, 21,054. The 0 here is in between a 1 and a 5, and that makes it significant. So this one has 5 significant figures. How many had 5? Be proud. There you go, Liam. Proud of you. Finally, let's see. 10's got a lot of things happening. These zeros are placeholders, so they're not significant. Then the 1 is. Then the 0 is in between 2 numbers, so that's also significant. That's 2. 7 is significant. And then the 0 afterwards is also significant. So that's got 4 significant figures. How many of you had 4 there? Oh, isn't that great? So on the test on Friday, there's going to be a part where you have to, just like this, tell me how many significant figures a particular number has, and there's 2 questions on it. So that's pretty straightforward. Okay. There's also a math portion. So let's look at math a little bit here. If you can read number 6 on the previous page, it says, with multiplication and division, the answer cannot have more significant figures than the measurement with the smallest number of significant figures. So the smallest number limits how many sig figs you can have. So I'm going to do some multiplication and division. That's this. Here's where the calculator comes in. You got it out? If I take, let's say, 1.38 times, I don't know, 12.413. If I plug that into my calculator, which you can see right there, 1.38, that's wrong. 0.38, that's also wrong. Times 12.413. It gives me a number with many, many digits on it. You can count there, let's see, 17, that's 2, 4, 6, 7 different digits that are significant on there. However, I can only use the number that's the smallest of these 2. So if you take a look there, this has got 3 sig figs, this one has 5 sig figs. And since the smallest number is 3, my answer can only have 3 sig figs. So I have to round it to the nearest number that will give me 3 sig figs. That would be 17.1, I guess. I just chop the rest off, so or round it down. So 17.1 is the answer there. I just rounded my 17.12994 down to 17.1. It gives it 3 sig figs, just like this number right there. Now what's important is that you'll have to do something like this in the test as well, but I'm not going to be the teacher that's checking that you're doing this two months from now, like on a lab, okay? So if on a lab you wrote 17.12, it is what it is. So 17.13, I'm not going to count you wrong if you don't use the correct amount of sig figs. However, this at least allows you to kind of think about sig figs and know that they're out there. Part of the Minnesota State standards for next year are that you have to understand significant figures. So that's why we're spending some time with them this year. Okay? But it's only good for Friday, and then I'm not really going to, be a Nazi about them for the rest of the year.
I think the ACT has a couple questions.
It's totally possible, yeah. I would not doubt it. All right, so let's try a couple more. Let's see. I had the ones. Oh, 12. I had a 12 there too. How about 123.79 times 14.105 divided by 5. Yeah.
Wouldn't 5 be one significant figure? You can't write the full answer.
Let's look it up. Let's check it out. So you plug it into your calculator. I typed a negative for some reason. Let's find out what it says. Divide by 5. And the number ends up being 349.21159 on the calculator. Okay. However, this has 5 sig figs. This one also has 5 sig figs, but this one has 1 significant figure. which is kind of a bummer. So I can only make this number have one significant figure. So it takes a number that's pretty much in the middle, and I'm going to end up rounding it down. So instead of 349, my best answer with the correct number of significant figures would be 300. I run it all the way down to 300. And that has one sig fig. Okay. So sometimes using sig figs, the rounding is fairly drastic. Now again, if you wrote, on a lab that we do sometime in like 3 weeks from now, you write this, I'm not going to count you wrong if you don't write 300, because that's not the person that I am. But just so you understand, this is a more correct representation of how well you measured something, or especially when you start to incorporate math in it. Okay, so the 300 there. One more, or do you want to stop? One more is for fun, right? Who cares? We got nothing to do. 15.3 divided by 12.09 times 16.78. Good job. Fun. Good test. Take a second, try it. Or just spin your paper on your desk. That's good too. It's a good use of your time for sure. Definitely helps you understand significant figures better. I hope your excuse is that you don't have a calculator. Yeah, because there's no way I have a drawer full of calculators either. Oh, so you just didn't even take a calculator out. Okay. It's good to know where we're all at. Let's plug this in and see if we can get it to the right number of sig figs. 15.3 times 12.09 times 16.78. Oh, sorry. I am freaking out right now. Look how many numbers I have there. 2, 4, 6, 8, 10 of them. That's 10 significant figures. You can't write all those down because that's way too specific for if these are measurements, it's way too specific. So you can only go to, this is 3 sig figs and 4 and 4. So you can only go to 3 sig figs. So that would be 21.2. You just get to chop it off. 21.2 is your correct answer. Questions about that? Again, if you wrote 21, not on Friday, because the test, there's like 4 or 5 questions where you need to write correct sig figs. But if when you're doing conversions on Friday, on the written part of the test, and you write 21.23, am I going to count you wrong? I'm not going to count you wrong. But if it's the significant figures portion of the test, then you probably get counted wrong. What about addition and subtraction? Great question, Maddie. Here's the addition and subtraction. Rule number 7. With addition and subtraction, the result can be no more certain than the least certain number in the calculation. So what that means is that you don't necessarily have to count significant figures. You're more interested in which measurement is the worst. So for addition and subtraction, plus and minus, and let's say we add, 7.8 plus 12.13 plus 9.071. Okay, still, add it the way you regularly would on your calculator. 7.8 plus 12.13 plus 9.071. What happened? Cool, look at that. I just picked those numbers at random and it's basically 29. That's so exciting. How come no one cares about that? Oh, thanks guys. That's pretty exciting. It's basically the highlight of my day. It says a lot if that's the highlight of my day. 29.001. So we're not counting sig figures right now. We're just counting which of these is the least accurate or least specific number. And this one goes out to the thousands place. This one goes out to the hundredths place. This one goes out to the tenths place. So my number has to be reported to the 10th. So 29, and there's no real rounding there. It's already 0.0, so let's go 0.0. That's actually a good example. Okay, this is out to the 10th place. This is out to the 10th place. That's how you report it. Number 2. One more of those. How about a subtraction one? 154.098 minus 101.3 minus, no, plus 89.3 plus 12. Try that right now and see if you can get the correct number of significant figures in your answer. That was me. Did you hear it? I'm pretty cool. Typey tape type. Here's the answer. I got 154.098. No way! Awesome! I just picked them at random, you guys. No, seriously, I've never even used this example before. This is the best thing that's ever happened to me. I'm so glad I'm recording this right now. It's so fantastic. Anyway, so it's the same as the first one. What are the chances? I just picked 2 radio stations, and then randomly I picked 12. Yeah, that's crazy pants. Show this video to your friends and family tonight, because it's pretty awesome. Move over all the other viral videos that have ever existed. Sorry, Charlie bit my finger. This is more important. Anyway, this is out to the thousandths place. This is out to the tenth place. This is also out to the tenth place, but this is out to the ones place. So my answer's got to be reported in the ones. And so all I can do is write 154. I have to round and stop there. No point, zero, nothing. So 154 is the best, most. If you're using correct significant figures, the best way you can do it. Again, if you wrote this, or even 0.1 or 0.098 on a real test, on a quiz or something like later, you're going to get it right. But there's 5 questions on significant figures on Friday's test that look like either these, where you're adding or subtracting, multiplying or dividing, or these, where you're just telling me how many significant figures there are. Do you have any questions about it?